Yesterday, AWS showed us how they can mess up your systems, but that was just a rehearsal for today's talk, because I will show you how to do it yourself. I'm Marco, and I joined a war against servers 8 years ago, and I write a blog called Serverless Live, and here are my open source projects: Serverless Spy, Lambda Live Debugger, and CDK Booster. The tool that is most useful for you is Lambda Live Debugger for remote debugging Lambda functions. It's free, open source. It's the simple solution for a really hard problem that Jan talked this morning. It supports old frameworks. How to lose your data? Well, serverless is like a holy grail of software development, but it comes with steep learning curve. Additionally, AWS have quite some quirks, and altogether, it might result in you losing your data or getting invalid results without even knowing. So, first example, what's wrong with this code? Well, we have a DynamoDB table with list of conferences, and we are using filter to find the one in Milan. Why would this code not work in some cases? Well, to figure that out, let's look how filter works. You send request to DynamoDB, and DynamoDB reads up to 1 megabyte of data, and then, and only then, apply a filter, and if no records match, you get no results. And that's it. And that is highly misleading. What you should do is take the last evaluated key that you received with the response and get another batch of results, and you continue to do so until you get all the data you need. But the first response with no results can be really misleading. So here's the fixed code. It's just a simple loop. Or you can use paginate scan, a helper function which is part of SDK, which does the same thing, but the code is much nicer. There is also paginate query if you would like to use it. Or even better solution, don't use filter, especially not in large data sets. You probably noticed that we use scan. Scan means reading the whole table, and if table is large, that is highly inefficient. So for that reason, use indexes to narrow down results, and then use filter if you really need it. Another DynamoDB example. You write a record into the database and immediately are reading it. What's wrong with that? Databases are meant for this case. Well, DynamoDB is eventually consistent, meaning you might not get the data you just wrote. And the delay can be especially long if you insert a lot of data and then use global secondary index to read it. Yes, you can enable strong consistent read, but note that this is slower, more expensive, and more chance of throttling. And even more important, it doesn't work on global secondary index, where it's the most needed. Another DynamoDB example, and this is my favorite. So you're batch inserting, or into totally different process, batch reading some records. What's wrong with that? Well, you might expect that if you don't get an exception, all the records are correctly written, or all records are correctly read. But that's not the case. In case of batch failure, you don't get an exception. You just get a list of failed items, and you should retry them yourself. I know it's confusing, but that's in documentation also. And not only that, DynamoDB is not the only one that behaves this way. If you batch insert into SQS, SNS, EventBridge, Kinesis data stream, Firehouse, etc., in case of partial batch failure, we're talking about batch operations, you don't get an exception, you just get a list of failed items. And you should retry them yourself with exponential backoff and jitter, which basically mean not retry them immediately, but with some random delay. Serverless systems are usually event-driven. To simplify, we send a message, an event from system to system asynchronously. And the key characteristic of every such system is that message can lose order or can be duplicated. Let's look at the order. Some of services guarantee order. Those are SQS FIFO, SNS FIFO, DynamoDB streams, Kinesis data streams, and some others. SQS FIFO and SNS FIFO are just a special version of SQS and SNS that are a bit more expensive and has less throughput. So think about if you really need them. All other services don't guarantee order. Next topic is duplicated events. And here is a very tricky question. Which of AWS services guarantee asynchronous or pull-based invocation of Lambda with the same payload exactly once, meaning no duplicates? I'm not talking about synchronous call like API gateway. I'm talking about SNS, SQS, EventBridge, Kinesis, etc. So which of those services will not duplicate message? None. And that could be really confusing, especially if you know that SQS FIFO and SNS FIFO offers deduplication, meaning you throw the same message into SQS FIFO and it removes duplicates. But when SQS calls Lambda and Lambda timeouts, or there is a system error, and you never know if the message was processed or not, well, the call will be retried, and here is your duplicate. So what you should do is design your system to be idempotent, meaning you must take care yourself that duplicated messages are processed only once. And what is also really important, you can find duplicated messages in less expected services. So a common pattern is to use Firehouse to load a lot of data into DynamoDB, and then use Athena to analyze it. You might expect, well, Athena has SQL query language, behave like a database. There is primary key that protects me from duplicates. No, there's no primary key in S3. And when you insert data into Firehouse, there is no way you can ensure there is no duplicate because of retrying. So if you're using this approach to store financial data and your balance doesn't match, well, that could be the reason. But it's really simple to solve since Athena has SQL query language. It's easy to remove duplicates, but you must be aware of the issue. Let's look at another design pattern, the transactional outbox pattern. It's a really great pattern. I love it, and you should use it. What it solves, well, you want to write data to DynamoDB and so also some other, and you want to do it atomically. You want both to succeed. So what you do, you attach Lambda to DynamoDB, and when the record is written to Dynamo, Lambda writes it to external system. Very simple, scalable, efficient. But what happens if external system fails? Or there is a poison pill message, meaning a message that cannot be processed. Well, obviously, DynamoDB stream will retry. But for how long? Well, for up to 24 hours. Then the data is gone. Well, it's a simple solution for that. Add that letter Q. But there is a catch. If you use SQS and SNS, those messages in that letter Q don't contain actual data, just a pointer to DynamoDB stream. And yes, DynamoDB stream is gone after 24 hours. But if you use SD as that letter Q destination, then it actually stores the data. But that's quite a new feature. Another thing it's important, if you throw messages in that letter Q, you, of course, lose ordering, which is one of key features of DynamoDB stream. So we started talking about that letter Q pattern. It's a common pattern in event-driven system. When you pass message from system to system, if it fails, after some retries, you throw them into that letter Q. Usually, you use SQS, but you can use other services, depending on configuration and availability. What is important, if you use SQS, you can store their records only up to 2 weeks. So configure alarms, and even more important, don't miss those alarms, which you probably will. It's really challenging to correctly configure that letter Q. So buckle up, this will be a ride. First example is simple. You have SQS, just attach another queue to the main queue. That's it. What about if you asynchronously invoke Lambda? Then you attach that letter Q to Lambda, or you use Lambda destination, which is basically the same thing, but you also get error message. You can use SQS, SNS, EventBridge, Lambda, S3, all of those. But if SNS or EventBridge invokes Lambda, then you have 2 data letter queues. The first one is attached to SNS subscription or EventBridge rule, and this one gets the messages that fails to deliver to the Lambda. And second data letter queue if the Lambda fails. So in this setup, the second one is more important. But if the target is like other, like API destination, the first dead letter queue is really important. Now, the last example regarding dead letter queue, we already talked about it. DynamoDB streams. Kinesis data stream is the same. With also the same issues. As I mentioned, if you use SQS and SNS, records in dead letter queue don't contain actual data. It's just a pointer to the stream. And for DynamoDB stream, that's valid only for 24 hours. Kinesis data stream is also only for 24 hours unless you configured it, which can be up to 1 year. And again, you can use S3 that get actual data. The easiest way to lose your data is by overloading your system. Every system has its limits, and if you exceed them, the system will throttle. Some of the limits you can raise by sending requests to AWS service support, but it's really hard to figure out which one you might exceed. So I strongly recommend you to do load testing. And Grafana K6 is an amazing tool for that, especially because you can write tests in JavaScript. Simple to use, very efficient. Serverless is challenging, but extremely rewarding. It's the easiest and probably in most cases also the cheapest way to build scalable and reliable systems. But it comes with some surprises. Thank you. No more servers.